Okay, now we're ready. Last time we looked at another example of inheritance, but we did not talk about, excuse me, we did not talk about constructors. In that example, there were no constructors to be seen. At least I don't think there were. So let's pull it down, take a look at it, and let's talk about adding constructors into the mix. Do keep in mind there's a lot of ways that you could do this exercise. So if you think of other ways to do it, it may entirely be correct. But in doing this exercise, there's certain things I want to get across, and the way I did it communicates those things. So let's look at what was done, and let's play around with it. All right, we have our sales rep, our junior sales rep, our senior sales rep, and our test class. In addition, we have a test plan. Now, the way that these are linked together is the sales rep is the superclass, it's the base class. All right? And in this example, there are people that are just regular sales reps. That's sort of the default. All right, nothing special about them. They're just a sales rep. Then we have junior sales reps, and then we have senior sales reps. Now, we know that it's valid to inherit junior sales reps and senior sales reps from sales rep because we can say the statement that a junior sales rep is a sales rep. Likewise, we can say a senior sales rep is a sales rep. So it passes the is-a test. This is a that, or this is an example of that, or this is a type of that. So since we have that, it passes the test. Therefore, we can declare the sales rep as our base class and inherit from that the junior sales rep class and the senior sales rep class. Can I rearrange these? Yeah. Junior and senior. If you notice, in the junior and senior, the only thing that we have is the stuff that's different. All right? We have all these functions defined and all these attributes defined in the sales rep class. We have the attributes that are protected. Protected attributes means that they are available in the class itself and in any subclasses. So I can access the sales amount in the senior sales rep class because it's protected. If it was private, I would not be able to. Typically, you're going to make the attributes in the superclass protected because under most circumstances, you want the subclass to be able to access those. All right? Now, notice we have gets and sets, and so on for those attributes. We have a get commission that calculates the commission for the regular sales rep, which is 10% of their sales. We have a get base salary, which returns $2,000. Again, in a more complex problem, there might be a formula to calculate the base salary, maybe depending on how many years they worked or whatever. But we're just going to hard code it as 2,000. We're just interested in showing how the inheritance works. And then finally, there's a get total salary of that adds up the base salary and the commission. Now, in both the junior and the senior class, we only code the differences, all right, with inheritance. So the only thing that's different, these attributes are still there. Junior and senior sales reps don't have any additional attributes, all right? And therefore, there's no need to code any attributes for them because these extend sales reps, it means it gets these attributes. Getting and setting these attributes is identical, right? A get function and a set function work pretty much the same. One takes in an argument and sets an attribute. The other returns the value of an attribute. So there's really no reason for the get and sets to be different for the senior or junior sales rep. Therefore, we don't need to duplicate that code. We define it on this level. Because this class extends that class, we get those functions also. All right? The only two that are different is the way that we calculate the base salary and the way that we calculate the commission. There's a different value for the base salary for a junior sales rep. There's a different value for a senior sales rep. And finally, the method for calculating commission is different. Regular sales reps get 10%, junior sales reps get 7.5%, and senior sales reps get 12.5% up to $10,000 and 15% for everything above $10,000. So that's all we do is we code those two different functions. Why don't we have to code this function, get total salary? Isn't that different isn't the total salary different for a senior sales rep and a junior sales rep? Right. It's different in terms of the results are going to be different, but the mechanism by which you calculate it, you call the base sales salary and get commission, add them together, that's their total salary. Now, what's different is not the way that you calculate total salary, but the way that you calculate the base amount and the total commission. Therefore, those two things only need to be overridden. All right. Any questions at all about this? We started defining some test cases. I think we put one in. First test case is for a junior sales rep. We create a junior sales rep object, give them a sales of $5,000. Their base amount should be $1,500. Their commission should be $375 for a total of $1,875. We actually ran it, and that's the results that we got. Okay? So we're doing this in a systematic way. We're documenting what the test cases are. It's good because we can then look at it and say, did we cover all the bases? Well, with this one test case, we certainly didn't cover all the bases. We had talked about last time how there probably should be at least 4, maybe 5 cases, right? We should test a regular sales rep. We should test a senior sales rep that sold less than $10,000 and a senior sales rep that sold over $10,000. And then maybe a senior sales rep that sold right at $10,000, like $10,000 and $10,001. All right? So we might not have 4, we might have 6, but we have about that many, 4 to 6 sort of test cases if we wanted to test this thoroughly. And we put them all in our unit test class, right? Because if it's our job to come up with these classes and make sure they're right, this is not going to be the whole system. This is going to be incorporated into some bigger application that has a lot of other stuff. But if we're the programmer that's responsible for this one section, if our assignment was to create these classes, when we turn it into the complete project, we want to make sure we did our job accurately, right? So it might be impossible to test it completely until the whole application is done, but we can still test our little piece of it. And that's exactly what a unit test is, where we're testing a piece of the puzzle and make sure that that works. And we can, as we see here, eventually this might be hooked up to a GUI, but we don't even need a GUI to do that. We can write a test class that has the test cases defined. We already said what those test cases are in our test plan. We write the code to test those, run it, make sure it's right. If we find a problem and correct it, we want to make sure that the change that we made doesn't affect anything else. So we'll go back and rerun all the tests and verify that a change that we made didn't break something that was unintended. I said before, one of the things I've heard more as a programmer than just about anything else is, I didn't change that part of the program, so it couldn't possibly have broken it. Well, sometimes things are connected in a way that you don't understand. Sometimes you mess up and forget that you made a change. Whatever. People are human. Because of that, you're going to test thoroughly to make sure that any changes you make don't go back and break something else. And again, the nice thing is if you define this test class and define the test cases in it, it doesn't take long to test it and prove that you didn't mess anything up, right? Like, again, I only have one test case, but let's say I go and change something. I'm going to go and retest it. And retesting it will simply constitute recompiling everything and rerunning everything. And we can look and say, yeah, that's what it's supposed to be. That doesn't take long if you've defined your test cases and you've created a unit test class and you run it through the ringer and test it. So even if there were 4 or 5 test cases in here, it wouldn't take long to do that. And that way, if you really didn't change anything that mattered, all right, you could prove to yourself in a few minutes that, yeah, I didn't break anything. Okay? So it's worth it to do that. Now, as we mentioned before, there's no constructors in this example. All right? No constructor here. No constructor here. No constructor here. What do we know about constructors? What happens if there's no constructor in a class? The compiler creates a no-argument constructor for you. And all that no-argument constructor does is it allocates the memory for the object. It doesn't do any of the default setting like a regular constructor would do. All right? So in this case, notice there's no constructor on SalesRep, on Junior SalesRep, or Senior SalesRep. Okay? But yet we still call a constructor. This is calling a constructor. Wherever you see new and the name of the class in parentheses, you're calling a constructor. So We didn't define a constructor, therefore what's being used in this case is that generated constructor, that generated no argument constructor. Now, what do we know about no argument constructors? All right, let me rephrase that. What do we know about constructors dealing with inheritance? What about constructors and inheritance? Yes. Yeah. One thing is before we create the subclass, we have to create the superclass. So if we create a member of the subclass, we first have to create the member of the superclass, and then we can create the subclass. So that's one of the rules. All right? Let's figure out how this happens here. This takes into account a lot of default behavior because we don't have any constructors at all. So, keep this in mind. Two things. If we don't specify any constructors, a no argument constructor is generated. That's fact number one. Secondly is, if we don't specify in the subclass which of the superclasses constructors get called, then the superclass's no argument constructor gets called. All right? The implication of that is I don't have to declare any constructors and this will work, right? Why? Because if I call the constructor on junior sales rep, there are no constructors on junior sales rep. Therefore, the no argument constructor gets called. All right? Is generated. Since there is no constructor, I'm not saying which constructor on the sales rep class gets called. Right? I'm not saying super and saying which constructor gets called because I didn't even write the code for this constructor. It's generated. If you don't specify which constructor on the superclass gets called, the no argument constructor gets called. Okay. So the bottom line is that if I have no constructors here, if I first call the constructor on the junior sales rep class, it's going to call my default no argument constructor on the junior sales rep class. That constructor is going to call the default generated no argument constructor on the sales rep class, going to do its thing, and then it's going to finish. So it works out okay if there's no constructors. But there's really a situation where you're not going to define constructors. So let's consider this. Let's change this test to just a plain old sales rep. We'll still call him J. So now we're testing a sales rep. And we're still creating a sales rep object, not a junior sales rep object. And sales equals 5,000. So the base should be 2,000, and the commission should be 500. And the total should be 2,500. Let's see if that's the case. It's correct. So it works. If I was smart, I would have copied that and made another test class. But too late. I didn't. I would have had another test case, rather. All right, I changed that test case instead. So it would have been smarter for me to copy it. All right. Now let's go and add a constructor on the SalesRep class. I'm going to add a constructor that accepts an employee name, an employee ID, an employee name, and SalesRep amount. So I'm creating a constructor on the SalesRep class. And I'm going to say PID equals arg PID. Name equals arg name. Sales amount equals arg sales amount. All right. I think that's okay. Now, look at my test case. What's going to happen when I compile this? Is it going to work? Form your answer in your head. Form your answer in your head what you think is going to happen if I try to compile this. Here's the SalesRep class. Has one constructor that accepts 3 arguments. Here's a unit test, which is how the code was written before. All right, let's see what happens. I get an error. I get the wrong kind of error that I was expecting. It doesn't know that this is a constructor. It thinks it's a method. That's what this error message says. And I forgot to specify a return value. Why does it think that it's a method and not a constructor? Yes. Because I spelled SalesRep wrong. I didn't spell with a capital R, right? What's a constructor? A constructor is the exact same name as a class. So a constructor for SalesRep is going to say SalesRep, and it's going to be spelled the same way. And it's case sensitive. So therefore, the compiler saw that and thought it was a method without a return value, and therefore gave me an error. See, again, sometimes I decipher these error messages. Now I go and fix that. Okay? Now maybe it will work, maybe it won't. We compile it again. Now I get a whole mess of errors. All right? I get 5 errors. Some of these are my typos. So let me go and fix those. Oh, that should be AMP. Okay. So I'll fix that one. I spelled that name wrong. I had accidentally deleted it. Let's see what we're getting now. All right, I get 3 errors. Let's see if we figure out why I get those 3 errors. Why do I get this error? This is in the unit test class. And it's this line that says SalesRep J equals new sales rep. Why does that give me an error? It worked before. Why does that line give me an error? Right. I didn't have it before and it worked. Right. The reason that this gives me an error is this used to work, remember. And if I do this, it'll work again. Works again. So what difference does it make when I put that in? I have now defined a constructor for my sales rep class. That means, first of all, when I go and create that item, I can't call the no argument constructor, because the no argument constructor only exists if I have not defined any constructors for that class. So when I declare a constructor for the sales rep class, the no argument constructor disappears. If I want there to be a no argument constructor, I have to code it. So I could fix this by doing this. Just putting a thing in there and not doing anything. All right? We'll talk about in a minute if that's a good solution or not. All right, it's probably not a good solution. But that'll fix things. Why? Because now there is no argument constructor, so the compiler won't complain. And if you notice, this will also get rid of my other problems. Okay. But that's not a real good solution, to put in a dummy blank function. That sort of seems like a duct tape and paperclip MacGyver kind of solution, right? It doesn't seem like a real solution. So we're going to take that out. So let's look at the errors that we get when I take that out. The first one, or one of them, is on the test class. Because I say SalesRep J equals new sales rep. I call the no argument constructor. There is no longer a no argument constructor, because I did not define one, but I did define another constructor. So the default constructor also does not get defined, which means I cannot call the no argument constructor, which means I'd have to call the constructor that I defined that has 3 arguments. The first one for employee ID, the second one for name, and the third one for sales amount. Now, if I do that, I don't need to call the sets anymore, right? Because I set those things all at once. So if I do that, that will get rid of one of the errors. All right? It gets rid of the one error that existed in the test class, because now I'm calling a proper constructor in my test class. I'm calling the 3 argument constructor that I defined. But I'm still getting an error on the sales rep class, the senior sales rep class, and the junior sales rep class. And it has something to do with the constructors that I've defined here. let's think this through. All right. There's no constructor on the junior sales rep class, which means what's the only constructor I can call? The no argument one that the compiler generates. All right. Remember that before a subclass can be created, the superclass has to be created. The no argument constructor on this junior sales rep, since it's generated, what does it call? It calls the no argument constructor on the student, sales rep class. All right? And guess what? That no argument constructor is gone. So it gives me an error. So sales rep now has this. There's no constructor on each of these. So therefore, I'm calling the no argument constructor on these, which will in turn try to call the no argument constructor on the superclass. Well, guess what? The superclass no longer has a no argument constructor because we defined a 3-argument constructor. So our options are put in a no argument constructor like I did a minute ago. That'll clear the error up. Or add constructors to the 2 subclasses. And that's probably the more likely thing that we're going to do. What we're going to do is I'm going to, in the junior class, I'm going to create a constructor that accepts those 3 arguments. And all it's going to do in turn is it's going to call the 3-argument constructor on the superclass. So now, there's no argument constructor on the junior sales rep class. There's a 3-argument constructor. So I can't anymore call the no argument constructor on the junior sales rep class. There's a 3-argument constructor. That 3-argument constructor explicitly calls the 3-argument constructor on the superclass. And that's okay because there is a 3-argument constructor on the superclass. If I were to do this, I'm going to get an error. Why am I going to get an error? Because since I didn't explicitly call the 3-argument constructor, it's going to try and call the no argument constructor on the sales rep. And guess what? There is no argument constructor on the sales rep because I've defined a constructor already. And therefore, this will give me an error. Same kind of reason as before. This is known as constructor chaining. All right? This constructor calls the superconstructor. Doesn't do anything on its own. It just calls the constructor on the level above it and passes the same arguments in. So a lot of times, especially when there's no attributes, this is how the constructors are going to work. You're going to have a constructor on the subclass level that calls the corresponding constructor on the superclass level. And at some point in the superclass level, it's going to take care and set the attributes. So to correct this completely, I need to do this. I feel this is one of those things that's hard to explain in words, but when you get to working on it, it should become more obvious. If it ever tells you that you don't have a constructor that matches a certain set of arguments, check to make sure that the constructors on the subclass and on the superclass align. Because typically it's going to work like this. The subclass is going to call the superclasses, and if there's any arguments, it's going to pass it. Now, I could have 3 constructors on here. One that only accepted, well, let's say 2. One that accepted a name and the amount of sales and the employee ID. One that accepted just the employee ID and name. And if I did that, I'd probably have them again on all 3 levels, where the subclasses constructor would simply call the superclasses level and give the 2 arguments. Now, thank goodness, this should compile. And it doesn't. Oh, I made a typo. I call that arg sales, and it should be arg sales amount. All right, and that compiles, and everything should work the way we wanted it to. So it's pretty common to have the same sort of set of constructors in each, whereas the constructor on one level will call the corresponding constructor in the superclass with the same number of arguments. Now, the only exception to that would be if there's some additional attributes in the subclass. If there was, let's say, for a senior sales rep, there was a bonus amount that they get added on to their paycheck for some reason. If that was the case, I might have a 4-argument constructor on the senior sales rep that would call the 3-argument constructor on the sales rep and use the 4th argument to set the additional attribute. Questions about that? All right. Next thing we're going to talk about is abstract classes and abstract methods. Okay? Now, an abstract class is a class that there is never going to be an instance of it in your program, in the real world. What do I mean by that? Let's think of pets, okay? I'm making a veterinarian's application, and I have a class for pets, all right? Because I could come up with something like this. I could create classes that look like that, where pet's a superclass, dog, cat, and rabbit are subclasses. Okay? Now, does that sound valid? Yes, that does, because a dog is a pet. A cat is a pet. A rabbit is a pet. A dog is a kind of pet. A cat is a kind of pet. A rabbit is a kind of pet. So that's valid. Are there some things that all pets share in common? That's from a veterinarian's perspective. Yeah. All pets are going to have a name, I would think. All of them are going to have the day that they were born. All of them are going to have the ability to calc their age. All right? So, those are 3 things about a pet that we're going to have. All pets have names, all pets have a birthday, and all pets, you should be able to calculate their age, right? If you know the birthday and you know the current day, you should be able to calculate their age. So that's 3 things. 2 of them are attributes, and 1 of them is a method, right? We can calculate their age based on their birth date. So we're not going to store their age, right? We're going to store their birth date as an attribute and do a calculation of their age if we need that. Now, every pet also has a kind of food that they like, right? So, get food list could be a method that returns a list of things that your pet eats. Get no food list. This would be the list of things that you're not supposed to feed your pet, right? Like you're not supposed to give dogs chocolate. At least so I hear. I don't know. I assume that's right. And all pets make a noise. All right? So maybe we're going to have a method that returns the kind of noise that they make. Now, we set up this structure, all right? Pet is sort of a generic class, right? People have pets, to be sure. We could form a list of the pets that everyone in this classroom has. But people don't have things that are only pets. People have things that are a subclass of pets. In other words, let's say if you called a veterinarian and you said, I want to get my pet examined. They're going to ask you, what kind of pet is it? Let's say in this case, this veterinarian only handles dogs, cats, and rabbits to make it easy. The receptionist is going to say, is it a dog, a cat, or a rabbit? Is it going to make sense for you to say, no, it's just my pet? Well, what is it? It's a pet. Yeah, but there's no such thing as just a pet, right? You have a dog that's a pet, you have a cat that's a pet, or you have a rabbit that's a pet. Which one is it? That's exactly what we mean by an abstract class. An abstract class is something that is more of a concept than a specific thing. A lot of things might fit into that concept, but more specific versions of them fit into it. So in other words, people have dogs, cats, rabbits. And yes, those are all pets, but no one only has a pet, and that's the end of it. That is known as an abstract class when you define that. And what is true of an abstract class? It means that you cannot create an instance of it. So let me download a little example I have from Canvas, and we'll take a look at it. We probably won't finish this example today, but I do want to introduce this concept to you. So I'll create two folders underneath this example, one for the sales rep example and one for the pets example. So I only did pet and dog, but we could easily expand this to do pet, dog, and cat, and rabbit or whatever. All right. Pet is defined as an abstract class. Now, an abstract class can still have regular methods in it. An abstract class can, for example, have gets and sets for all the things they have in common. So I could have a get name and set name, get weight and set weight. And it wouldn't have to be an abstract method. But I am going to have some things that are abstract methods. In other words, what kind of sound does a pet make? There is no default sound for a pet. All right? Different pets make different sounds, but all pets make some kind of sound. All right? And please don't argue, what if your pet's a tarantula or something? They make sounds too. Okay, they're just very quiet. All right? And certainly all your pets eat food. But there's no default food that pets eat, right? Lizards eat bugs or worms. Dogs eat a lot of stuff, all right? Cats eat nothing except what they feel like eating, and so on. The point is I can't define any logic for the make sound method for pet or the get food list for a pet, because that's different for each kind of pet. I have to define that on the specific subclass of pet. And that's exactly what I do. Here's the get food method for a dog. Here's the sound that a dog makes. And then I add an additional one for what a dog says when it catches a frisbee. The idea here is the dog can extend an abstract class, but we cannot create an instance of the abstract class because people don't have pets. They have a specific kind of pet. So these are more abstract classes are sort of conceptual in nature. They're things that don't really exist in the real world, but conceptually they exist because they have some attributes and methods in common for all pets in this case. All right? We'll pick up on this next time and go a bit more over abstract classes. All right, we'll see you up in lab.